demonstration. We're just here showing the system for you, for the groups. So the system itself has 10 lasers. It's gonna have 405, 488, 561, and 640. It's also gonna have 445, 594, 514 and 594. These here, these are for CFP, YFP, and RFP. Some people use it. The main lasers that are the most common are these four. So DAPI, FITSI, TRITSI, 640. And this system also has near infrared lasers. So there's three. There's a 685, a 730, and a 785. So for near infrared, it's used for multiplexing to add more, channels, more dyes. But it's also a lower energy laser, so it's less phototoxic on your samples if they're alive. And also the longer wavelengths go deeper into the tissue, and so you can get deeper imaging in your samples. With algae, I think it's okay, because how big is your sample typically?
It's very tiny, less
tiny?
than maybe 0.1 millimeter.
Yeah, and we can even load it up. So
It's just 1 ml
okay,
samples.
awesome. Yeah, so this is
We just
fairly
need to
thin.
put the cover on it.
Oh, the cover slip.
Yes.
Okay. Do you want to go ahead and do that, and we can go ahead and load it? The only thing with the cover slip, since it won't be mounted, we could probably tape it on. What do you think, Armando?
Yeah,
Okay.
just do the same thing.
Yeah.
This one is, so there are several insert holders with the system. Usually these are depending on what you need. This is a core, so normally I would recommend like the multi-wall plate holder, and then also like this is a 4-slide holder, so you can have multiple samples loaded at once. This is a universal one that actually moves in and out.
Yeah.
This is probably the most common one. It works for, those matte tech dishes that have the glass bottom. You could actually use those in the future. It might be the easiest. Either those or the ABD chambers. They come with thin glass bottom, so you could just load your sample onto it, and you would be ready to image without. Exactly. Mm-hmm. And they're reusable. I mean, it depends if you can wipe them down with ethanol. They're reusable, so you could always think about that. And so for this, we can set it into the insert holder. I'm gonna add more objectives in a minute, but for now I have the 20x. What do you normally image with? Which objective are you currently? It might be in that one. It's in a black box just like that. The core is looking into a confocal. Only buy what you need, and you can always. So the beauty about our system is you can always upgrade later. You don't need to do that off the bat. Because these systems, or our system at least, it's fully upgradable in the field, right? You can add detectors if you want, channels. You can do that, add lasers, all in the field. So this system here has 6 detectors. Each one of these boxes is 2 detectors. So 2, 2, 2. So it's a total of 6 detectors on this system. That means you can image 6 colors at the same time.
Wow.
And is the slide it should be upside down?
The slide should be upside down because this is an inverted system. So this system, the objective is in the bottom. So your cover slip should always face the objective. And I can go ahead and put it now actually, since you have them. The 60x oil would be great. I'm gonna put one more objective on there. And then, just really quickly move it by hand. It's okay. Just gonna add more objectives because we just finished installing it last week. And then I flew back home to Houston, and now I'm back. So, this is the 60x. Put that in position 5. So usually you'll have this full with your objectives that you normally use. So I'm gonna find focus with the 20, and then we'll switch over to, oh yeah, sure, we'll take it. I think for algae, we won't need the 10, but you never know. No, but we're probably gonna have to put the full set of objectives before the next group gets here.
So do we need to bring our USB?
You will at some point, either today. I'm gonna be here all week. So if you want to come back for your data tomorrow, the data stays on the machine all week. So don't worry about that. There we go.
Is it still plugged in? Excuse me.
Yeah, did we reconnect?
I'm glad to put it in my house.
Yes, exactly. You know, funny enough, when we get hired, they let us have. So on a typical system with the photomultiplier tube, the signal would be somewhere between 0 and 4,000. For this system here, it's actually photon counting. So it not only gives you the range from 0 to 4,000. Actually, in this case, it's 0 to 65,000 because the dynamic range is so large of the detectors. It also tells you when you hover over each pixel, there's 3 photons here, 4 photons here, 5 photons here. So if you're doing quantification, then having those raw values of how many photons are there is actually much more important for that. They're more accurate. And our system is linear, so the more data you add or the more laser you add, it's gonna linearly increase up to 2,000 photons of your sample. Most samples don't have up to 2,000 photons. So you're gonna be linear in most of your working range of your samples. So those are the biggest differences, is the detector on the system, it's a chip detector. So linear and quantifiable. And this is the software here. So essentially everything on your left is kind of like, your most important options that you would have. And then here on your right is just, you would tell it to take the image here, and a couple of other options. If you're doing 3D stacks, you can set some options here for those 3D stacks. You're focusing the sample already. So your sample is, are there any, what fluorophores are on the sample currently?
No.
No,
We didn't
none.
add any.
Okay, just bright field and like maybe autofluorescence or something like that.
They
Found
are.
it in Fitzy.
Fitzy? Okay, awesome. So let's do that. So I'm just gonna switch from the eyepiece back to the software. And then I'm going to tell it the dyes that I have, which is what I would do on a normal day. I'm just gonna go ahead and leave these channels on here, so Fitzy, and I'll see if I see any kind of autofluorescence in these other three, or in these other 3 channels there. And what I'll also do is I'm gonna leave bright field imaging on too, to see if we see anything in bright field. Here we go. And so I'm gonna hit live. I'm just gonna add a little bit laser power and see if we can get some autofluorescence from the sample here. And this is 20x?
Yes.
Correct. Okay, awesome. And then let me just make sure that I'm actually, I think that's there. That's the sample there.
Yep.
So this is autofluorescence. There we go.
What is this sample?
It's with zinc oxide.
And then
RGB.
this is, yeah, so we want to switch probably to the 60x to see what's the most we can see. And then here, and this is all autofluorescence. And this is here, this is bright field imaging. So this is just typical bright field image that you would see in a regular microscope as well. That's all autofluorescence. Let's back that down. 5. Okay. So we have autofluorescence in all of your channels actually. In some